All right, this is our topic 2, and this is on uniform motion and speed. So it says any object that travels in a straight line at a constant speed is said to have uniform motion. So it says, does this bowling ball pictured to the right travel with uniform motion? So if we look at the bowling ball, in order to figure out whether it's traveling with uniform motion, basically what we've got to look at is the space in between. So if the space between each of those balls, I guess, is the same, then we would consider it to be traveling in uniform motion. So uniform motion, it's constant speed. The way you might travel with uniform motion might be, I don't know, on the highway in your car. You can put your car on cruise control. So cruise control will keep your car at a constant speed. It's really hard to keep yourself at a constant speed when you're not on the highway, for instance, just because there's people that drive slower, faster, all that stuff, things that could be in your way. But yeah, in general, a constant uniform motion would be that constant speed. It says, what about a vehicle traveling at an average speed of 110 kilometers an hour down Highway 2? Well, that's what I just said. Basically, it's easy if it's at a constant speed. If it's saying an average speed, that tends to think of constant. Is it possible to move with uniform motion for extended periods of time? It is, I guess, if you're using your car, but again, it would be very difficult as a person to move at a uniform motion. Even if you're walking, you might be walking faster at some points and slower at others. So it's really difficult, and for extended periods of time, definitely more difficult as time goes on. So average speed, this is the average speed of an object that may be determined by comparing the distance traveled by the object to the time required to travel that distance. So this is our very first formula when we're talking about physics, is velocity, or v, our speed, is equal to our distance over our time. So when we have something over another thing, we're talking about dividing. So really, this is our formula that we're going to use to be able to calculate the speed of something. And we use that, your car uses that when it's calculating the speed of you driving in your car, for instance. You're going to see your speedometer is going to tell you your speed. So if you're saying you're going 100 kilometers an hour, that's 100 kilometers within 1 hour. So if you're driving at a constant speed of 100 in your car, then you would go 100 kilometers in 1 hour, okay? So that's just, you're taking your speed is equal to your distance divided by your time. It says, note, calculations of average speed assume that an object is moving with uniform motion. So whenever you see something saying average speed, we're thinking that it's going in uniform motion, okay? And in real life, that's really unrealistic because most things don't go in uniform motion. But it's there in the sense that if you feel the need, you can do that. I don't know why. I've already done these. I may have opened the document for this that is from last year. Let me just double check that I am doing the right. Okay. Well, I'll go over to this one just so that I can do these calculations out with you, as opposed to me have already done them from previous time. So it says a vehicle. So how we do this, I'm going to do a practice problem here. But remember, when we're doing these types of questions, we've got velocity, speed, is equal to distance over time. Okay, that's our formula. So when we're reading these word problems, what we need to do is we need to pick out the pieces that are the V, the D, and the T. Okay, so we're looking for our speed, we're looking for our distance, and we're looking for our time. Okay. I sort of put a little curve on my T there just because sometimes would get confused between T's and pluses. Anyway, it says a vehicle travels a distance of 120 kilometers an hour. So that's one piece of information. It says distance. So if we look at our formula, we've got V, D, and T. D stands for distance. So we're going to write 120 kilometers in our distance time. That's our distance in this question. Next, over a period of 1.5 hours. So what we look at, what's left, is it either our speed is 1.5 hours or our time? And hopefully you know that hours is a unit of time. So we're going to write 1.5 hours there. Our V, our speed, is what we don't know. So we're going to calculate that. The question's saying calculate the average speed. So that's what we need to figure out. So I'm going to rewrite this formula over here. And then what I'm going to do is I'm going to plug in the pieces we know. So we don't know what V is, so we're going to leave it as the letter. Next, we're going to write in our numbers for distance. So we're going to replace the D in this formula with 120. Okay. So that's where that's coming from. We're just replacing that distance. We're putting the divide, so we're just keeping it the same, and we're going to replace that T with the number we have. So our number for T is 1.5. Okay. So right there, this is going there, and I really should, use maybe a different color. So that T, that's where that's coming from, okay? So we don't know what the V is, but we know what the distance and the time is, so we can plug those in. Now what we've got to do is we've got to divide those. So if we take 120 divided by 1.5 in our calculator, we get 80. And 80, that's great. That makes no sense to anyone if you're not going to put in the units. So it's really important that you're putting in your units when you're doing these types of questions or any question in math or science. So our units here are kilometers. See, we've got kilometers right there. And we've got hours on the bottom. So how we write that is exactly the way, exactly the way that it's written. So kilometers over hours, okay? And that's what you would hear when you tell someone your speed. You would say, oh, you're going 80 kilometers per hour or an hour. So that per or that an, that's signifying that little line there. It's divided by, okay? So that's our answer. That's it. That's all we got to do. 80 kilometers an hour. I hope that the math that we're doing in science is pretty easy, and you will hopefully not get too stressed if you're not a math person, because all we do in science is really just dividing and multiplying a couple numbers. It's not too extensive here. So let's try another question. It says a tsunami. Okay, first of all, before I even start reading the question, getting ahead of myself, I'm going to write down the formula. And then I'm going to write down my little data table, I guess is what I call it. Then I'm going to fill in the pieces that we know. I always like to write down what we know and what we need to find, because it helps me to sort of figure out where we're going with this question. All right, so it helps to visually put it all together. So it says a tsunami travels a distance of 4.0 times 10 to the 6 meters. So that is a distance. So I'm going to write it into the distance. Over a period of this many seconds. What is that? 36,000 seconds. So that's, again, if you know seconds is a part of time. So 36,000 seconds. Our velocity, we don't know. Okay. So what we're going to do here is we're going to set it up and plug in those pieces of information. We're going to put in these pieces of information into our formula. So we don't know what our velocity is, but we do know what our distance is, which is 4 times 10 to the 6. And that's in meters. So notice how our last question was kilometers an hour. This one's meters per second. And that's normally what we're going to be measuring when we're talking about things in science. They normally use meters per second. When we talk about cars and like driving, we use kilometers an hour. If you're in America, you would use miles per hour. And that's not something that we'll really ever use in this class. But something to note, if you ever are driving, for instance, in the States, you would have to sort of adjust your speed, which is, again, if you see a sign that says it's 60 miles an hour, well, if you're going 60 kilometers an hour, you're going way too slow. So you can see on your car, it'll actually have the miles on your speedometer, so you can sort of adjust your speed that way. But anyway, let's go back to this. So our distance divided by our time, and our time here is 36,000 seconds. It's a lot of seconds, but it's really not that long. So when we calculate that all out on our calculator, we will get an answer. And I only have my iPhone to do this. I don't have a calculator at home. So what I've got to do to put in those, and maybe I should show you this on here, and I can do that. Just 1 second. So on my phone, or your phones, you can do this too. Remember that you have the option to be able to flip. So putting that flipped, and then we can put in our units here, or we can put in exponents. So let me just go back to here to figure out what the numbers are that I need. I need 4 times 10 to the 6. So how we do this on an iPhone, you guys do have, I did send you home calculators, so you should have it, but I'll show you how to do this. So 4, and then if you put this little EE button, or you can put 10 to the X. I'm going to go 10 to the X. I don't think that's actually how you do it. See, I don't use this much. If you do the EE button and you put 6, that'll give you the right answer. So I'm doing 4 times 10 to the 6. So what I do is go 4 EE 6. And if I equals that, that's giving me 4 times 10 to the 6. And then I want to divide that by 36,000 seconds, which is that. And it gives me my answer of 111.1111111. All right. So if I go back to here, I need to write that as my answer. So 111 point. I'm just going to round it to 1 decimal place. Because why not? And then this is meters per second. So remember that's meters over seconds because we've got meters over seconds. So you need to keep those units in your answer. That's really important. When I'm marking these things, I'm going to only give you half points for getting the number and half the points for putting the units. All right, so each of those is worth 1 point, the answer, and then the units. So even if you get the answer wrong, as long as you have the units, you're getting half of the marks for the question. All right. The next one's saying convert the average speed of tsunami determined in question 2 into kilometers an hour. All right, so it hasn't shown us how to do this, but we will go right into how we're going to do that. So what was our answer? It was 111.1. And this is meters per second. And I think we did that in the last lesson, if I remember correctly. We did do this and converting, because because we did some conversions and stuff in that topic one. So just to refresh you on this, if we're going from meters per second to kilometers an hour, which is what the question wants us to do, we need to use a couple conversion factors, or this is how I like to do it. So we want to have kilometers over hours, okay? I put ones beside those, so we have kilometers on the top and hours on the bottom. What are we changing our kilometers from? Well, we're changing it from meters. What are we changing our hours from? We're changing it from seconds. What you'll notice here is that meters is on the top, and on the bottom we'll get rid of it. Seconds is on the bottom, it's on the top, we'll get rid of it. So we're going to be left with our units of kilometers over hours. And the numbers are what we need to put in here. So to focus on like this specific conversion, what I think about in my head is I think about, well, 1 kilometer is how many meters? And if you remember this, hopefully, it's 1,000. So there's 1,000 meters in 1 kilometer. And then the next conversion factor we need to look at, how many seconds are in 1 hour? Well, this is one that you might not be in your head explicitly, but it's one that I told you need to remember is 3,600. So 3,600 seconds is in 1 hour. All right. So that is basically it. Now all we got to do is multiply across the top, multiply across the bottom, and then divide. So on my calculator, I'm going to put 111.1 multiplied by, just to show you what I'm doing here. So we're taking this number, multiplied by this number, multiplied by this number. So we're multiplying it by 1. You probably don't need to do that because you know it's not going to change the number. But we do need to multiply it by 3,600. And if I do that, I get an answer of 399,960. And then we're going to multiply across the bottom. So there's nothing here on the bottom, but we got 1,001. So 1,000 times 1 is going to be 1,000. Remember, hours are on the bottom and kilometers are on the top. So if we divide those numbers out, we will get our answer. And I get an answer of 399.96. So 111 meters per second is equivalent to 399.96 kilometers per hour. So when we put this into kilometers per hour, it makes it like more realistic because we're used to thinking that way when we're talking about driving, for instance. That's really fast. Like none of us have gone 400 kilometers an hour in our car. That's a really fast tsunami. Okay, so that puts it in perspective to us to see how fast this wave is coming. And I think that's what it was talking about. Yeah. All right, and then let's do this number 4. It says a plane flies at an average speed of 694 meters per second. Whoa, Miss V, you need to settle down. You need to first write out the formula. So this is the formula we're using. We got velocity, distance, time. So it's saying that the average speed is 694 meters per second. So velocity, 694 meters per second. Calculate how long it would take the plane to fly around the world. So it's telling us we're going to need to calculate the how long. How long is the time? So I'm going to put a little question mark there. And at the very end of the question, it says a distance of approximately 4 times 10 to the 7 meters. So 4 times 10 to the 7 meters. All right. So we need to calculate time. If we look at our formula, our time is not on one side and the rest on the other. So what I'm going to do here is I'm going to move some things around so that we have time by itself. And then we have velocity and distance, or average speed and distance, on the other side. All right. So we start out with v is equal to distance over time.